Hey everybody, welcome to Bill Sky the Assembly Guy, and in this video we're going to continue the console input lesson, and we're going to show you how to take whatever the user types in and convert it to an actual number that you can do mathematics on. Now, as you may or may not know, if you didn't watch that previous video on console input, I'm going to do a little review on this one. But the way that it works is that when the user enters something from the keyboard into the computer program, it's always ASCII. And if you're not sure what ASCII is, we're going to take a look at that too. So when that ASCII value, or that ASCII array, that array of ASCII characters is actually stored in your input buffer, you have to do something with it before you can do math on it. And there's multiple ways of doing this, but I'm going to do it the universal way, where we actually go through every character of the ASCII string and we actually convert it to a number, or take away the ASCII value and then convert it to a number that we can do math on. And we're just going to do integers today. We're going to do floating point in the future, but let's get to it. So before we really do anything, I have a little program here, and I call it Linux x86 console input output. Now you can use the console input program that we did in a previous video, or you can do something like this. And really what this is, and we can quickly go through this, I have a little input buffer here of 128 bytes, and then I have the length of the buffer. And what I do is I print out a message that says, hey, I would like you to input some data, and then we go ahead and we call my function. Now these are using the Komanetsky assembly language functions. Again, if you're using your own console input function like we did in the previous video, that's fine. They work exactly the same. So you read the string, and it says reading a string because you really are. When you input a number, the user's not really inputting a number, even though the keyboard values might be numbers. They're really not. They're ASCII values, and we're going to take a look at that. And then after we input that value, we print it to the screen. So what I'm going to do here, and let's get rid of this. So what I'm going to do here is I'm going to go ahead and build this. And it built just fine. And now let's just run it so I can show you how this works. Okay, please enter some data. Hello there. I think that's from the previous video. So okay, so that's cool. So now let's go ahead and let's put this input integer stuff here. So we don't really need this right here. We don't need to ask the user, so we're going to get rid of this. Okay. And so I don't know, maybe that is right. Anyway, so let's go ahead and build it again, and let's take a look. Okay, please enter an integer. So I'm going to enter 1, 2, 3. All right, great. So I entered 1, 2, 3. I don't really print it. I mean, I could, but let's actually take a look at the internals of what I entered in there. So I'm going to debug it. And let's go to the line of code that's after the input of that string. So I'm going to go down here, and I'm going to put a breakpoint on this no-op right here. And actually, this isn't using the Komanetsky functions. This is actually using the functions that I did in previous videos, so that's cool. Okay, so I'm going to put the breakpoint on that no-op, and I'm going to run it. The screen says enter an integer. I'm going to type 1, 2, 3, and now we're stopped at this no-op. Now, what does the data look like that the user typed in? Well, it's in the input buffer. So I'm going to go down here to memory, and I'm going to go to input buffer. And right now I'm displaying it as string, so that's why you see 1, 2, 3 \n, that's the enter key. But let's right click on that, and instead of string, let's look at hex. So you can see that every byte, the 1 is actually 31, the 2 is actually 32, the 3 is actually 33, and the \n is 0a. Now you can't do math on these. I mean, there are ways on the Intel assembly language that you can do that, but you can't do it that I know of on ARM or Mac for that matter, which the newest Mac is ARM. So it's pretty important that we need to be able to convert that. Now there's no way for you to actually enter data natively into an assembly language program that is an ASCII, because the entire keyboard is what we call an ASCII keyboard. So some of you may not know what this ASCII thing is. So I'm going to go to ASCII-table.com, and let's go ahead and go down here. And let's take a look at the number 1. So there's the number 1 right there. It has a hexadecimal value of 31. Well, isn't that what we saw? The number 1 has a hexadecimal value of 31. The number 2 has a hexadecimal value of 32. If we go back to our debugger, there's our 32 right there. So these are ASCII values. And if I tried to add one ASCII value to another, if I tried to add 31 to 32, what will we get? We get 63. And if I come down here and I look for 63 hexadecimal, if I can get out of the advertisements here, a 63 hexadecimal is the lowercase letter c. So you really can't do math on these ASCII values. You have to convert them first. And that's a little overview of what the ASCII table is. So you have to put together an algorithm, because none of this is built into the assembly language. Assembly language gives you the absolute minimum that you need to get the job done. And so how do we actually do this? Well, I actually wrote up a little flowchart, and some of you might be going, oh my God, he's insane. He wants to look at a flowchart. Well, but this is the way I figure out how to do things. And when I wrote this code that we're going to use in this video, I started from scratch. So I wrote up this flowchart, and for those of you who don't know what flowcharts are, it would be a good idea for you to go take a look. But let's take a look at how I did this flowchart. So as a real quick summary, a flowchart is a graphical way of showing the logic of an algorithm. So you have a start and you have an end, and you can see and I call it stop there. So we're just going to zoom in, and then each box has a certain function. So this box right here with the vertical lines, this is a predefined function box, and it means that there's already a function out there. I already created my function read string, and I'm going to say read a numeric string into input buffer. Input buffer is the name of our variable. So we go ahead and do that. And then what we do is we have to create a loop counter. Now, what are we actually going to do? We're actually going to start from the end of the number and go left, and we're going to multiply a factoring variable by 10 for each digit. And we'll get more into that as we move. But we need the loop counter. We need to know how many digits the user typed in. So we have to get the actual input length, which is in EAX, and we're going to put that into a variable or into another register. So that's going to be our loop counter ECX. Then we calculate the end of the string, because we want to actually start at the end of the string, the least significant digit, which in our case was 3, because we typed in 1, 2, 3. We want to start at the 3, multiply that by our factor of 10. The first one would be 10 to the 0, which would be 1. So 3 times 1 is 3, and then we add that to some accumulator. And so we go ahead and we have to start at the end and we have to go to the beginning. We have a power of 10 value. I told you just a moment ago, 10 to the 0 is 1, 10 to the 1 is 10, 10 to the 2 is 100. So as we move from right to left, we increase the factor of 10 that we're going to multiply that digit by. And then right here we say AL is equal to the ASCII value that we want to actually convert. Then we subtract 30 from AL. Why am I subtracting 30? Well, if you remember, if you looked at the ASCII table, 1, the decimal digit 1 has an ASCII value of 31, hexadecimal. So we subtract 30 from that, and we end up with the number 1. 2 has a hexadecimal value of 32. 3 has a hexadecimal of 33. So you subtract 30 and you get an actual number. Now, it's still an ASCII value. We haven't actually converted it to an actual integer, because we then have to multiply it by its factor of 10. And that's what this multiplication does. And then we add that multiplied number to the total. So after we do that, we have to increase our factor of 10, so we just multiply it by 10. We decrement ESI, so we go to the previous, or we go to the next value to the left. We look to see if our loop counter is greater than 0. If it is, we continue the loop. If it's not, we're basically done. So this little flowchart, and I'll put this little flowchart, a link to it in the description of this video, but it's a good way to figure out how to write the code. So just to kind of, I'm going to show this to you again. I'm going to run it. I'm going to put in 1, 2, 3. And let's go over what we're going to do. So what we're going to do is we're not going to start at the \n. We're going to start at the 33. Remember, I typed in the number 1, 2, 3. We're going to subtract 30 from 33. We're going to get a 3. We're then going to multiply that 3 by the power of 10. Our first value will be 10 to the 0, which is 1. So we'll multiply 3 by 1, and then we'll add that number to an accumulator. Then we're going to move to the next digit. It's going to be a 32. So we're going to subtract 30 from 32. We're going to get a 2. We're going to multiply that by the power of 10, which would be 10 to the 1. The first digit is 10 to the 0. The next digit is 10 to the 1. So that'll be 2 times 10 will be 20. We'll add that to the accumulator, which originally had 3 in it, so now it has 23. Then we move to the left, we get the 31. We subtract 30 from that, we get 1. We multiply that by the 10 to the 2, which is 100. So 1 times 100 is 100. We'll add that to the accumulator, which originally had 23 in it. So now we're going to have 123, and we can actually do some math with it. So I hope that little overview makes it easier to understand what we're going to do. Okay, so let's actually look at the code that we're going to do here. And using my flowchart, and you can have the flowchart up, you can take a look at the flowchart. I like to print them off and have them next to me when I'm coding. So after you do a read string, whenever you read something from the keyboard, EAX always has the number of characters that the user typed in. So I'm going to put EAX, save the number of digits entered into ECX. So that's our loop counter. Now, we don't want to use the \n because the user always types the enter key. So what we're going to do is we're going to decrement ECX. So that's going to be ignore the \n entered by the user. All right, so we're going to go ahead and ignore that. Now, we have to calculate what is the address of that last digit. So what I'm going to do is I'm going to move into ESI the address of input buffer. And I believe that's what it was, right? Input buffer. The address of the number entered. So we put that into ESI. Now, what do we want to do? Well, we want to move the address. So the address in ESI is going to point to the most significant digit, which would, in our case, was 1, 2, 3. Remember, we were testing this with 1, 2, 3. So right now, ESI is pointing to this. We want ESI to point to that. We want to start at the least significant byte. So we already have that information inside of ECX. We already know where that is. So what we're going to do is we're going to say add into ESI ECX. Point to the last digit. We're going to be going backwards from 3, then 2, then 1. Okay. Now, because ESI is the actual first digit and we have 3 bytes, if we add 3 to ESI, it'll actually take us to the 4th one. So we're going to decrement ESI. And you can try not decrementing ESI and see what happens, and you're gonna get a funny result. Okay. Now, what do we want to do? We want to now calculate what our power of 10 will be. So what I'm going to do is I'm going to move into EBX1. That's our power of 10. Counter. And I'm going to move into EAX 0. So this is simply initialize our accumulator register. And EAX is going to contain the actual result of our calculation or our conversion. So I believe I added a couple of other things that are not in this flowchart. As I was testing it, I made some changes. It's always a good idea to update your flowchart as you find things. But that's kind of what we're doing here, right? We set it, there's our power of 10 value, there's our EAX. So the flowcharts, our code is following the flowchart pretty well. So everything is ready for the loop. So I'm going to call this convert loop. That's going to be the beginning of our loop. And what does our flowchart say to do? Our flowchart says put into AL the digit that ESI is pointing to. Now ESI is going to be pointing to the 3 from our 1, 2, 3. So we're going to put that into AL. So I'm going to say move AL ESI. Place an ASCII digit into AL. Now, why are we not using EAX, or if you're doing 64-bit RAX? Because we don't want 4 bytes or 8 bytes. We just want a single byte, because an ASCII value is really just a single byte, unless, of course, you get past extended ASCII. So we're just going to do that into AL. It's going to make life a lot easier. So what does the flowchart next say to do? The flowchart said subtract 30 from AL. Good, so let's do that. So let's say subtract from AL 30. Remove the ASCII portion. Okay, and now what I want to do is I want to multiply that value by the power of 10. So if I look back at our flowchart, it says multiply EBX, multiply EAX by EBX. And remember, EBX is our power of 10 value. Right now it's equal to 1. So it's going to multiply EAX by 1. Now, why are we going to multiply it by 1? We're in a loop, and we don't want to have to write more code just to not multiply it by 1. So I'm going to say multiply EBX, multiply by power of 10 to, I don't know, what are we going to say? Deal with decimal position. Maybe I could come up with a better than that. Okay, so now what I want to do is I want to add that value to some accumulator. Now, because we're in 32-bit, I'm running out of registers here. So what I did was I created a variable up here called the total, and it's a double. So what I'm going to do is, instead of adding it to EAX, I'm going to add it to the total. So I'm going to say add the total EAX. Now notice we're using EAX again because we used a byte. We stuck the AL, we stuck the digit in the far right portion of EAX. The rest of it was all 0, so that's easy. So add the value to our total variable. All right, great. So now what we want to do is we want to move left 1. And if you remember, our address pointer was pointing all the way to the right, the least significant byte. So let's move left 1. So I'm going to decrement ESI, point to the next power of 10 digit. Okay, so now the pointer is pointing to the 2 in the 1, 2, 3. So we've processed that. Now we want to point to the 2. And that's what that line 74 is doing there. And then what I want to do is I want to increment or multiply my power of 10 by 10. Right now my power of 10 is 1. I want to multiply that by 10. So the 2 will be multiplied by 10, which will give us 20. So I'm going to move into EBX, that's our power of 10. I'm going to multiply. Oh, you can't multiply by a literal. I can't do this. I can't say multiply 10. Won't let me do it. So, or this. Won't let me do it. So what I have to do is I have to move into EBX 10, and then I'm going to say multiply EAX by EBX. So that gives us our 20, or actually our 10 at this point. And then I'm going to move into EBX EAX. So that's all we're doing here. We're just setting up our next power of 10. There we go. Okay. And I think we're done. So then I'm going to say loop, convert loop. All right. So let's go ahead and save and build that. Built just fine. And we're going to try 1, 2, 3 again. So I think it'd be a good idea to actually show you the total variable as we process this. All right. Now let's make sure that I have my breakpoint in the right spot. We're going to put the breakpoint right there. And let's run it. Okay, so I'm going to put 1, 2, 3. Now here's our ASCII 1, 2, 3, 31, 32, 33. What I want to do is I want to take a look at, what was the variable name? The total. So I want to take a look at the total. Instead of bytes, I'm going to right click on it and call this words. I'm going to call it hexadecimal. All right, so there's the total right there. All right, now this is going to be decimal because 1, 2, 3 this routine is only for decimal numbers. So I want to look at this as unsigned decimal. So we're back to unsigned decimal and it's a 0. Okay, so we're going to go and get ready for the loop to start up. So we're going to put some data in there, set up all those variables. And now we're going to move into AL, ESI. Now let's take a look at the registers. Here's EAX. I'm going to move AL into ESI. Now that should be the number 3. It is 33, right? Hexadecimal 33. If you look at ASCIItable.com, it is the keyboard 3. So what I'm going to do is I'm going to subtract 30 from it. So now it's 3, but I still can't really do math on it because I don't have the whole number. I don't have 1, 2, 3. So I'm going to go ahead and multiply EAX by EBX, which currently has a 1 in it. You can see EBX right here has a 1. I'm going to step over. It's still 3. That's fine. I'm going to now add it to the total. Now I'm going to go to memory. Step over. Okay, so now our total variable has a value of 3 in it. I'm going to go back to registers. Here's ESI. That's the address of where we found our ASCII 3. I'm going to subtract 1 from it. It's now D. So it went to the left one. I'm going to set up a power of 10. Now let's watch EBX right now. That's our register. It should turn into a 10 after I get done with all that. And there you go. So EBX now has the value of 10 in it. And I'm going to now loop. Okay, so now let's move the next digit into AL. The next digit is 32. Remember, it was 1, 2, 3, and now we're on the 2. So we're going to go ahead and remove the 30. Now it's a 2. We're going to multiply it by our power of 10, which is a 10, which will give us a 20. Now, the hexadecimal value is there. The decimal value is there. So it gave us a 20. I'm going to go ahead and add that to the total. I'm going to go to memory. We have a 3. Step over. Look at that. Now we have a 23. And now we're going to go ahead and go to the first digit or the next digit to the left. We're going to set up our power of 10. Let's take a look at EBX. Right now is a 10. And now it's 100. So you see how we move left, we multiply by 10, and we get there. Now, one important thing is remember if you use EDX in this, every time you multiply, that's going to be overwritten. So I'm not using EDX at all in this because it's needed for the multiplication. All right, so let's take a look at the last one. Here's our EAX. It should be a 1 of 31. Yep, there it is, 1. We want to take away the 30. We multiply it by EBX. Remember, EBX has 100 in it. It now has a value of 100. We're now going to add it to the total. There's a total of 23. It's now 123. Awesome. So we go to the previous. Now there is no previous digit, but we go ahead and do that, and we leave the loop. So now the total has the value 1, 2, 3 in it, and now we can actually do some math on it. So what I could do is I could move into EAX, the total, and then I could increment EAX. And we could actually take a look at that to see that we can now do math on it. So I'm not going to debug all the way through this. Let's go ahead and let's put a breakpoint down here on the move. Let's put 1, 2, 3. Now we're going to be looking at EAX. We're going to copy the total into EAX. It's 1, 2, 3. We're going to increment EAX. It's now 1, 2, 4. So we can actually do math on it. Wow, that was cool, right? That was only integers. There's a lot more that you can do here. You can check for periods and invalid values, right? Because right now, this code is just doing integers and it's assuming the user typed a valid integer. Let's take a look at a couple other things that you could do. So back in our code here, what we could do is when we look at a character, we could make sure the value is between 30 hex and 39 hex, which would be 0, 0 to 9. If not, set the carry flag and leave the loop. Now, why are we setting the carry flag? Well, we might want to set the carry flag to turn it on and say, hey, there was an error in the user's input. What else can you do? Well, actually, that's really all you have to do here to verify your data, is as you're processing each digit, make sure it's between 30 and 39. And how can you do that? Well, I can move into AH 30. I can compare AH with, how do we want to do that? Compare AL with AH. Let me see. Jump if below 30. So if it's less than 30, entry error. Then I can move into AH 39. Compare AL, comma 39. Jump if above to entry error. And entry error would look something like this. Display an error message. So that's what you could do there. And I think that'll actually work. So you want to make absolutely sure. Also, you want to make sure that jump below is for unsigned integers and jump above is for unsigned integers. I'm having a senior moment right now. I can't remember. I think it is. That's for unsigned. So entry error is not going to have to do something. Now you're going to want to jump around that error. You don't want to actually do it. So we're going to have a, there we go. So this will actually display an error message. Well, this actually doesn't do it. You're going to have to write the code in there. So this right here is just going to make sure that the user has not typed in a non-numeric ASCII value. All right, I just love writing this kind of code. It's really neat because we're adding features to our program that can be found in higher level languages. We're getting an idea of how the compiler works. And there's a lot of other additional ideas you can do here. You could do a user input that allows for negative numbers. Don't forget, don't allow two negatives or two positives, or a negative and a positive. You can put some of that code in there. You could also do one on decimal, allowing for floating point numbers. You may need to know more about IEEE floating point formats, which we're going to be talking about very soon, but you want to be able to do that as well. All of my Komenetsky functions allow for that. You might want to take a look at how those work, how they operationally work. But also, you want to do this kind of stuff with a flowchart. I can't tell you how important it is to use flowcharts to get the ideas figured out, get all of the conditions figured out before you even start coding, and it's a really great place to start. It also helps to self-document your program. So until the next video, keep on coding in Assembler.